Hello and welcome to this video. This is again Valompo. I think this is 2013 summer. Excuse me. I think it's summer anyway. Anyway, this is a good question because it's on sort of the strange part about ligand exchange, which is worth watching, I think. So there's the question itself, but I don't want to look at the question for now. I want to give you a quick example of a ligand exchange. So let's push this up a little bit. Okay, and let's have a look at the reaction I think we did in class, but I can't honestly remember. All right, copper ions. Okay, and we're going to react to them with hydroxide ions, and we're going to get copper hydroxide. Okay, so that's basically the reaction. We need two of those, don't we? All right, so what's going on here then? Well, we've got our copper ions in solution, Cu2 plus. We've got our ligands going backwards into the board, into the page. Ligands coming out, ligands up, ligands down. Okay, and in this case, I'm going to put water. So these are water ligands. Actually, I've just realized I've done something wrong already. I'll change that in a second. So this is, obviously, this guy here is Cu, H2O, 6 times. And the oxidation number of water is, the copper is 2 plus. Okay, and what I want to change is these two ligands here. Okay, just quickly. Now, as I say, I may have done this in class. I honestly can't remember. Okay, and there I'm going to change these for water, and they were water. I'm just changing them a little bit like that. Okay, so now I'm going to react to this with, how do I do this reaction? I'm going to do it with ammonia, aqueous ammonia. Now, ammonia reacts with water to form ammonium ions and hydroxide ions. Okay, and that's the source of my hydroxide ions. This is why ammonia is basic, because it produces these guys in water. All right, so what's going to happen then? Well, hydroxide ions are from the aqueous ammonia. Okay, so we're going to add ammonia here. Okay, and then if you remember, we tend to add excess ammonia and we get a dark blue solution. But I'm going to add ammonia here, but the bit that changes everything is the hydroxide ions. The ammonia doesn't ligand at the moment. What happens is the hydroxide ions do something. And there's two hydroxide ions coming to my complex. Now this here, let me try and get a different color. Show it for just nice contrast. This hydrogen jumps onto there, and this hydrogen jumps onto there. So what we end up with is Cu2 plus. These ligands stay the same. Okay, the ones around stay the same. So this is water, water. This one down here is water. This one up here is water. But these two are now OHs. Okay, and we have two waters as well. All right, because of the proton exchange. Now, what is this? Is this a ligand exchange reaction? Well, not really, because the ligands haven't been exchanged. Protons have just come off the water molecules of the ligands. So this is actually an acid-base reaction. Okay, I hope that makes sense. That's an acid-base reaction. All right, not a ligand exchange. So you would think, some people might think, well, haven't the hydroxides replaced the waters? And no, the answer is no. It's an acid-base reaction. So this, strange as though it seems, but this is not ligand exchange. Okay, this is an acid-base because protons from the ligand have gone onto the hydroxide ions and given us water. And anytime you see a proton exchange, it must be acid-base. Okay, so let's try and answer the question now. All right, so what's the first one? Well, the first one, well, you have water as ligands, and then you have ammonia as ligands. So that straight off looks like ligand exchange, and that is. There's nothing wrong with that. Second one, well, you have water as ligands, all right, and you end up with Cl minus as ligands, so that's also ligand exchange. Third one, well, this one, oxidation number of ion is, oops, no, it's not 2, it's not 3, it's 2 plus. And it's 3 plus here. So this is an oxidation and a reduction, so this one must be a redox. Okay, the next one. Now, what have we got here? We've got 6 water molecules there, and we've got 6 water molecules there. We have OH minus here has gone on. So what am I going to call this one? I'm going to call this one a ligand exchange. Okay, is there an oxidation state change as well? This is 2 plus here, and this is 2 minus here. Okay, so I can't see anything. Oh, hold on. No, we've got OH. The OH minus is here. State as OH minus is here, so there's no proton transfer. So I don't think there's anything going on here but ligand exchange. Okay, oh, there's one thing we could say, I guess. This guy is soluble, and iron hydroxide, this guy is insoluble. So this is a tricky one, but you could also call this precipitation. Now, I've looked at the answer scheme, and you don't have to have two ticks. It's only one tick per line. I'm just telling you, you could have picked this one or this one. Okay, it's not a redox. It's not an acid base. It's a ligand exchange and a precipitation. This next one, well, there's 2 plus here, and there's 3 plus here, so this one is a redox as well. That's good enough to get you the mark. Is there anything else going on? I can't see anything else going on. Maybe there is. I'll check later. But that looks like that's all that's happening there. Anything else going on? Not that I can see. There may be an acid-base reaction there somewhere because the hydrogen here. Oh no, I don't think there is. Okay, so that's just a redox reaction there, isn't there? This next one, well, we start off with H pluses and we end up with water. So there must have been some sort of proton exchange there. So this must be an acid-base reaction. All right, because the protons must be going somewhere and they've gone to water. So that's an acid-base reaction. Now, I've looked at the syllabus, sorry, the mark scheme, and it also says ligand exchange. I don't think it is. I must admit, the chromium trioxide is a strange thing. It's not ligands as we would call them. So I think Cambridge is being nice here by accepting this one. However, I don't think it's a good answer. Okay, I think they're just being nice. I think it's a bit above our pay grade, but I wouldn't call that one a ligand exchange. This next one, what's this guy doing? Well, if you look here, this is 3 plus. And if you look here, let's have a look. It's 3 plus as well, I think, isn't it? Yeah, still 3 plus. So it's not a redox. Is it an acid base? Well, we have an OH here. It must have gained a proton to form water. So I'm going to call that one an acid base one. Okay. Is it ligand exchange? I wouldn't call it a ligand exchange. I just call that an acid base. But again, the answer scheme has called it ligand exchange. And what they've called a ligand exchange is one of these waters, H2O 3 times, has gone down, H2O 2 times, and one of the hydroxides, OH3, has gone to OH4. So if you remember what we talked about earlier at the start of the video, this has happened. Okay, this here, let me put it over here. This kind of thing has happened. Okay, so I personally wouldn't call that ligand exchange. Again, I think it's Cambridge being nice to us, and they say we'll accept ligand exchange, but I think that's that's just an acid-base reaction. Okay, but again, as long as you get one of these ticks, you're fine. The last one, chromium is 3 plus here, chromium is plus 6 here, so this is a redox for sure. Anything else going on? Well, I'm looking here. You got OH minuses. Let's have a look. 4 of those. Well, an OH minus here must have gained a proton. So I'm going to guess it's an acid base as well there to form the water here. Okay, I'm guessing on that one a little bit, but there must have been a proton exchange, mustn't there? So it must be acid base to some extent there. Okay, I can't remember what the mark scheme says, but if I'm wrong, give us a shout and I'll redo the video and try and answer any questions. So please, please criticize the video, no problem at all. And if you don't understand anything, let's dig deep into the nasty nooks and crevices we don't understand. All right, take care.